Hello, welcome to Math with Mr. Dobrescu, to the rescue. Today let's take a look at finding the value of x that makes this equation true. So we have a pretty complex equation here, negative 2 to the power of 4x plus 2 divided by negative 2 to the power of 2x equals negative 2 to the power of 12. Now before we solve this equation, I want you to take a look at these two examples here, because once you understand these examples, we can manipulate this equation in order for us to find the value of x. Okay? Let's take a look at example 1 here. We need to solve for x, and we have 2 to the x equals 8. What do you think should be the value of x in order for us to get 8 as the answer? Right? Remember equations? They have to be kept in a balance. The left side should equal the right side. So we need to get 8 on the left side of the equation. So what do you think we should put for x here in order for us to get 8? Let's try. 1 is too small. Let's try 2. If we put 2 for x, that would mean 2 times 2, which is 4, is not quite 8. How about if we put 3 for x for the exponent? If we put 3 for x here, that would mean 2 to the power of 3, which means 2 times 2 times 2. And 2 times 2 is 4. And 4 times 2 is 8. And actually it checks. So we can say the value of x should equal 3. Okay? So we manipulated here. So the value of x should equal 3. Can we do something else? Can we do something to 8 in order for us to get to the same conclusion? How can we break down 8 as? So if you want to break down 8, we can have 8 as 2 times 2 times 2, 3 times. Because 2 times 2 is 4, and 4 times 2 is 8, right? It's the same thing. So you see that 8 can be written as 2 to the power of 3. So 8 can be written as 2 to the power of 3. And here we have 2 to the power of x equals 2 to the power of 3. What do we notice? We notice that the bases are the same, and then we can see that on the bases are the same, also the exponents should be equal to each other. You see that? We came up to this conclusion. X should equal 3. Just like our answer here. X should equal 3. The conclusion we came. So remember, if we can do something to our equation to get the bases to be the same, then we can conclude that the exponent must be equal to each other, and that's going to be our answer. Okay? Let's take a look at the second example. Let me erase this now. We're going to look at example 2 here. Here we have 3 to the x equals 27. Now, what do you think should be the value of x, right? Let's try again. Try 1, too small. 2, 3 times 3 is 9, not enough. How about 3? 3 times 3 times 3 indeed is 27. So here the same thing, we can say x equals 3. Because we can write 3 to the power of 3 equals 3 times 3 times 3. This is 9 times 3 is 27. It's exactly what we get, right? So we can say that 27 can be written as 3 times 3 times 3, or we can say 3 to the power of 3. So 27 can be written as 3 to the power of 3, and then we still have 3 to the power of x equals now 3 to the power of 3. And again, we can conclude, because now we have the bases are the same and the exponents equal to each other, so x equals 3. I want you guys to keep this in mind as we work on our problem, right? If we try to manipulate something in our equation to get the bases the same, then we can conclude that the exponents should be equal to each other, just like we did in our small examples here, right? Okay, we got the bases the same here, and exponents equal to each other, and the same we did for the first example. Now let's take a look at this example here. In order for us to have the same base here, we have something more complicated, and we need to expand this. We need to expand the numerator. So we have negative 2 to the power of 4x. It means negative 2 to the power of 4x times negative 2 to the power of 2. That's what it means. Remember that rule of exponents. If we have the same bases, we keep the base, add the exponents. So we went back and we decomposed this into this. Over negative 2 to the power of 2x equals negative 2 to the power of 12. Now, what else can we do here? We can go further and we can try to break this up into something to look similar to the bottom here. So here we can say, we can have negative 2 to the power of 2x times negative 2 to the power of another 2x, right? We broke this down into this, right? The same base, add the exponents, right? And we still have another one there, negative 2 to the power of 2 all over negative 2 to the power of 2x. And all should equal negative 2 to the power of 12. Okay? And now we can see something really interesting happening. Now we can see, because we have products here, negative 2 to the power of 2x times negative 2 to the power of 2x times negative 2 to the power of 2. Now we can simplify negative 2 to the power of 2x, one of these from the top with this one from the bottom, right? They went away because we decomposed this into this. Many factors multiplied together, but now we can see that those two simplified. So now we don't have the denominator any longer. Let me erase this example we did so I can continue with the problem here. And then let's see what we can get. Okay? So far we were able to get rid of the denominator. And now we are going to continue to see if we can solve for x. Because that's what the problem. They are asking us to find the value of x that makes that equation true. And then we are going to check our answers to see if we got the right value of x. Okay, let's continue now. Let's continue and see what we get. So now we have negative 2. So we have negative 2 to the power of 2x times negative 2 to the power of 2. That's from the top. We don't have denominator anymore because it's simplified out. Equals negative 2 to the power of 12. Now, do you guys see something really interesting? We have the same bases here, right? Take a look. The same base, the same base, the same base. And remember, based on our little examples we had earlier, if we were able to get the bases to be the same, right? Now we can conclude that the exponents should equal, right, to that. So first of all, let's combine those two together, right here. So negative 2 to the power of 2x times negative 2 to the power of 2. Remember that becomes negative 2 to the power of 2x plus 2. Okay? We combine those two together. Equals negative 2 to the power of 12. Now the same thing. The bases are the same. And now we can equal the exponents. So the exponent for this base is 2x plus 2. And the exponent of this base equals 12. Just like we did with our small examples, 2 to the power of x equals 3. And 3 to the power of x equals 27. Remember that. And now we just simply solve for x. We have a two-step equation. Solve for x and get our answer. So we have to subtract 2 on both sides here. 2 and 2 simplifies out. So we have 2x equals 12 minus 2 is 10. And the final step, we have to divide both sides by 2. 2 simplifies. So we get x equals 5, final answer. So our answer, find the value of x that makes the equation true. X should be 5. Okay? So now if we plug 5 into our equation, we should get a true statement. Let's try that. Let me use a green color right here. And I'm going to try to write a little bit smaller. So, sorry, I'm going to write a little bit smaller. And let me use blue. Okay, so we start from the beginning. So we have negative 2 to the power, instead of x, we are putting 5. So we have 4 times 5 plus 2 over negative 2 to the power of 2 times x is 5 equals negative 2 to the power of 12. Negative 2 to the power of 12. Okay, let's see if we get negative 2 to the power of 12 on this side of the equation, and then we are going to get the true statement, and our equation should be okay then. And let's continue here. So we have negative 2 on the top to the power of 4 times 5 is 20. 20 plus 2 becomes 22, divided by negative 2 to the power of 2 times 5 is 10, equals negative 2 to the power of 12. Okay, now we are going to use the quotient of powers property. So we have the same base, and then we subtract the exponents. So here we have negative 2 as the base, and we are going to subtract the exponents. 22 minus 10 equals negative 2 to the power of 12. And we know that 22 minus 10 becomes 12. So negative 2 to the power of 12 indeed equals negative 2 to the power of 12. So we can say that we got the right answer, right? We got it. That's a true statement. We got the right answer. Therefore, x equals 5 is the answer for our equation. So x equals 5 makes this equation true. Okay? So please remember, when you have this type of equations on a test, make sure you try to decompose these, break it apart into different multiple factors, series of factors, so we can simplify the bottom with one of these on the top in order for us to use that property, right? When we get the bases the same in an equation, the exponents will equal to each other. Thank you so much for watching, and I appreciate you watching. This is a little bit more complicated example of solving exponents. And please don't forget to like and subscribe, and I'll see you in the next video. All the best to you.